Decision tree. There's somebody is calling. I think because of delay, I got confused. Okay, what is decision tree? Using decision tree, what we can do, what kind of problems we can solve it. So decision tree is something like, for example, if you put a tree upside down, how it looks like, right? So that is how a decision tree will be there. Okay, so you have some root node. You have the root node. This is called your root node. And you have the branch node. This is called your branch node. Okay, branch node or decision node. Okay, it is also called as a decision node. It's kind of a flow chart, right? Most of you would have used a flow chart during college time or during your other college studies, right? This is your branch node, and this is your This is your branch node, and then here again you will have something like leaf node. This is called your leaf node. The leaf node, it is also called as a terminal node. So just beneath the leaf node, you will not see any further branches. This is the last node that is there in your decision tree. If you put a tree upside down, how it will be? Your tree is like this, right? Your tree will be like this, upside down, right? So you have the branches. Let's say you have a branches, right? The branches are like this. Your root is there here, right? Your root is this one. So that is what your root node here. And here you can see the branches. At the end of the branches, you may see the leaf node. It is called a leaf node or terminal node. Okay, so what can we do with the decision tree? What kind of problems we can solve? Using decision tree, we can solve both the regression or classification problem. We can solve regression or classification problem. Okay, and unlike the linear and logistic regression, it doesn't require data transformation or data pre-processing. So you don't have to convert the categorical column data into numerical column. Okay. So what is the prerequisite for a linear regression, logistic regression? What is the prerequisite for linear regression, logistic regression to fit a model? You need to have both input features as well as the output features. The same thing is applicable with the decision tree as well. But in the case of decision tree, your input features need not to be numerical. Unlike linear and logistic regression, in the case of decision tree, your input features need not to be numerical. Okay, so you can have the mix of both numerical as well as a categorical. If you have a categorical column, it doesn't require any treatment. Decision tree can handle it automatically. In case of any outliers, it takes care of it automatically. In case of any outliers or missing values, decision tree takes care of it. Okay, that is why I told you it doesn't require data pre-processing. And also another advantage decision tree is with the decision tree, or the decision tree helps us to find out the feature or it does the feature selections. Okay, it does the feature selection. What do you mean by feature selection? All of you, please type it in the chat. What do you mean by feature selection? We discussed a feature selection. See, 100% attendance is important, and at the same time, your concentration should be here, and you should be able to reply it. Yes, Anwar, you are correct. Jamal, you are correct. Soumya, you are correct. Deepa, you are correct. How about Soundarya and Anwar, you are correct. Yes, Soundarya and Jay Prashant. So, what do you mean by feature selection? So, what is that? Jamal mentioned that feature selection is nothing but including the features, the optimal number of features, which helps predicting the target outcome variable. You are absolutely correct. And Soundarya, even you two responded. Okay, Soundarya says feature selection. With feature selection, we can make sure that we are not including all the input variables. We are going to include only the input variables that helps predicting the target variable. Excellent, excellent. Okay, except one, rest of you all responded. And Deepa, yes, your answer is somewhat close by, but it's a good try. Okay. Okay. Anyhow, I explained you by reading the others' response, right? Soumya and Soundarya and Anwar. Jamal, yes, I'm looking for a reply from Jamal as well. Okay. Decision tree helps us to do the feature selections automatically. Okay. We don't have to do the feature selection explicitly like RFE. We have used it, recursive features elimination. RFE we discussed as part of linear regression as well as the logistic regression. What is outliers? Outliers we already discussed as part of descriptive statistics, right? So descriptive statistics we discussed. Outliers can influence your your line, right? Best fit line. In the case of linear regression we discussed. Even in the case of logistic regression, make sure that you don't have outliers in your data set. But outliers is pretty common, but you need to cap it. We'll discuss about how to cap the outliers a later session. And also in case of any missing values, we have discussed about how to perform data imputation. The other important feature of decision tree is you can solve both regression as well as the classification problem, unlike your linear regression. Yes, Jay Chandran, Jay Prashant, you responded now. Okay, good. Reducing input variable by using relevant data. Not relevant data, reducing input variable, correct. Reducing input variable based on the significance of the features, okay? What do you mean by significance? The p-value. P-value is less than alpha for those features are significant, right? Yes. So now we will go ahead and take a look at what exactly the how this algorithm works, decision tree. We have something called random forest. There are two algorithms that are very much popular. Random forest and other one is gradient boosting machine. Okay, so we will take a look at what is random forest is all about, and we'll explain in detail and how it works, right? For example, okay, you have see in the case of decision tree, we fit a model with a single tree, whereas using the random forest tree, instead of relying on a single decision tree, it creates multiple trees. Okay, before I proceed with the random forest, let us I'll give you a simple example. For example, you want to buy a car, you want to buy a 8-seater sports utility vehicle, okay, XUV vehicle. You want to buy the luxury car, right? The 8-seater car, and it is a very expensive one. It's 30 lakhs and above. Okay, you are ready to buy the XUV vehicle because you are going to buy it for the next. You want to use it for the next 5 to 8 years. Okay, so what will you do before you buy a car? You will find out which brand is good. Let's say you decide to buy a specific brand. You decide to buy a specific brand. In that case, what will you do? What will you do? What kind of actions that you do it? Will you blindly close your eyes and go and book the car, or what you will do? What you will do? Yes. Anwar says, I will go and review the feedback. Very good. Then internet, I will go and review the feedback. Okay, what other things that you guys do it? What other things that you do it? Very good, right? You go and review the feedback. What else? But how do you know the feedbacks given are the genuine, right? Genuine. Whether it is proper feedback given, correct feedback, or wrong feedback. How do you know that? What are the other steps? What are the other steps that you do it? Simple thing. Simple. Don't think too much. You will ask your friends and relatives, right? You'll ask your friends and relatives, or let's say your office mates, your colleagues. You ask your colleagues. Okay, you ask your colleagues, and then you decide. Let's say you in your company you have close to 300 employees are there. You are sending a group email ID to everyone, asking that I'm planning to buy the XUV vehicle, okay, Mahindra XUV. You want to buy a Mahindra XUV vehicle. You are asking everybody's feedback based on the majority's response, right? Majority says, hey, you go ahead with the Mahindra XUV, it's really good. Right? So based on the majority response, you decide. Let's say out of 200 employees, 150 out of 200 employees, let's say 50 employees, they have vehicle. Out of 50, 20 employees, they bought Mahindra XUV. Out of 20, what they say is out of 20 people those who own Mahindra XUV vehicle, they say almost 16 people, they say, hey, it's really good, worthwhile if you go for Mahindra XUV. It is value for money. Out of 2016 people, they give you positive response. Yes, yes, yes. So the same way the random forest works. It doesn't predict the class level based on an individual tree. It uses multiple tree, more than one tree. Look here, this is your decision tree. Multiple trees will be coming into picture. In the case of random forest, tree 1, tree 2, and 3, 4, 5, and 6. You just think, these trees are like humans, okay? 6 people are there. You want to buy a Mahindra XUV vehicle. You are, asking these 6 guys, right? So all say out of the 6 guys, he says, yes. He predicts yes. He says, yes. Each tree predicts. This guy says no, and this guy says yes, and this guy says no. So out of 6, how many of them said yes? 4, right? Majority is 4. So the predicted label will be assigned to a specific record, or the observation is yes. Majority voting. This is called majority voting. Like election. We don't get the opinion from a single person. Multiple trees. Similarly, the random forest, what is this? It goes by the majority voting by all the trees. Okay. So each tree predicted label is, maybe it's a yes or no, but majority is yes, hence it will assign your transaction yes. For example, whether I can approve a loan to a specific customer. let's say many customers, they applied for a loan with your bank. 1,000 customers, they applied for a loan. For each customer, what it does is it fits multiple trees, and then it predicts the class level for each customer based on the majority voting. If the majority voting, for example, customer one, multiple tree, and customer two, let's say no, yes, no, yes, no. So majority voting is no. For this second customer, it says no, don't give him a loan. It says yes, you give him a loan. Right? So majority voting. So this is in the case of classification problem. As I told you, the decision tree, you can use it to solve both regression as well as the classification problem and the classification problem. In the case of classification problem, it goes by the majority voting. You understood what is majority voting with this simple example. Okay, in the case of classification, majority voting. So what is regression? How does it works? If I ask you, let's say you plan to sell a product. Let's say you developed some product. You want to sell it in a market. Right? What you do is, so your challenge is how much price you need to how you can price it, right? How much can I price it? Okay, let's say you developed something like what product? You developed a laptop. Okay, you bought all these spare parts from various shops, and then you assembled it. You put some brand and name for your laptop. You want to sell the laptop to your customers, but you don't know what price you need to quote it. So what you do? Go and, yes, Anwar, you are correct. What Anwar says is, I will go and check the internet with the same feature of my laptop, other brands, how much they quoted it. Very good. Right. So, but again, just because the features, whatever your laptop supports with the other brands, you cannot blindly put it. So what you do is you can ask, even in this case, you ask your multiple people. So can you give me the price for why don't you suggest a price for my laptop? My laptop gives, these are the features. Let's say each person predicts, it can be 20K, and other guy says it is 15K, other guy says it is 22K, other guy says 19K. Different people predicts different price, and finally it aggregates the prices. Okay, in the case of regression problem, even in the case of regression problem, random forest creates multiple trees. Each tree gives the predicted price, and all the prices will be aggregated. It takes the average of all the trees prices, 20K plus 15K plus 22K plus 20K plus 20K. So whatever the average value will get it, that value will be assigned to your laptop as a predicted price. So now you are pretty clear. So in the case of random forest, it builds multiple trees, but it builds multiple trees simultaneously, not one after the other. Okay, since it creates the multiple trees, it will parallelly or simultaneously, the performance is pretty faster. The training time will be pretty faster. Okay, in the case of classification problem, it goes by the majority voting. In the case of regression problem, it goes by the average of the predicted values by all your decision trees, all the decision trees. It is that much simple. You understood, right? Okay, next one is the gradient boosting machine. Okay. In the case of so it is also, see, random forest. They use a term called bagging. Okay, random forest use a technique called bagging to create multiple decision trees. So in the case of bagging, it uses some bootstrap sampling. That means some data points may be repeated in different samples. See, this tree may be using sample 1. This is your training data. In the training, let's say in the training data, 1,000 records are there. So the sample, here it does the sample 1. Okay, and then sampling 2. The second tree will use the same training data, but not necessarily whatever the data used to train your first tree, right? It may be different from the first tree sample data, but the basis is this training data. Okay, but there are cases, let's the sample three also the basis is training data, but in the case of sample 3, maybe sample 2, whatever the data is used, same data may be used here. In addition to the sample 2 data, some other data would have sampled in the training data set. Okay, out of 1000 records, let's say in the sample 1 you have 700 records, and here maybe write 800 records. Sorry, here out of 800 records. Here you have maybe let's 750 records. Not necessarily all the records to be same. The number of records for each sample for each tree is different, but maybe a overlap. One tree's sample data may have some overlap with other trees' sample data. Okay, or sometimes it will be independent of other tree. Okay, that is called bootstrap sampling. Randomly select a subset of the data, training data with replacement. Okay, that is how it works. And also the other advantage of random forest is it provides a measure of feature importance. Which features are important? Input features are important to train your model. Okay, so the advantage is here reduced overfitting. Okay, the randomness introduced in both the data sampling and feature selection helps reduce overfitting compared to individual decision trees. Instead of making the decision based on the individual tree, since it fits multiple trees, right, it avoids, it helps us to reduce the overfitting. Okay, they may ask this question, what is overfitting, underfitting? We explained to you several times, right? Next one is feature import. It helps us to identify most important features in your data set. Let's say in my data set, I have 100 columns are there. 100 columns are like, input features. I don't have to use all the 100 features or columns to train my model, right? So out of the 100 input features, which features are, helpful, that, that is identified automatically by the random forest. Okay. It is robust to outliers. In case of any outliers in your data set, it is pretty robust. You don't have to do the data imputation also. Outliers, okay, in the case of outliers. And also, it can handle missing values without the need for imputation. Okay. But what are the limitations of random forest? The training time, right? So since it has to train large number of trees, maybe sometimes you may require 250 trees or 500 trees. The training time may be a bit more because the large number of trees requires a computationally expensive thing, right? And memory usage. It can be memory intensive, especially for large data sets. And complexity wise, the model can become complex with large number of trees, very difficult to interpret. Okay, so but with random forest, you can interpret in a pretty simple way. Okay, that is the advantage of random forest. To summarize, the random forest is a powerful and flexible ensemble learning algorithm. It is also called the bagging method. So random forest uses bagging method. Bagging is something like, what do you mean by bagging? What do you mean by bagging? So bootstrap sampling, I told you, right? It randomly selects the subset of the training data set with the replacement, and then it constructs a decision tree. It constructs a decision tree using the bootstrap sample. It constructs the tree with the bootstrap sample. That is what bagging is all about. And also the random forest falls under ensembling method. Okay, ensembling. So I'll just write it. Okay, ensemble learning. Ensemble learning. So ensemble, we pronounce it as ensemble. Okay, ensemble learning algorithm, right? So whatever I explained, right, that is what your ensembling algorithm. In the case of ensembling algorithm, when it comes to random forest, it uses the bagging method, which means it creates multiple trees And in each, and then it does the bootstrap sampling. Each sample is generated with replacement. But let's you have in this sample you have 1, 2, 3, 8, 10 records are there. Maybe in this one, right? Maybe you have 1, 2, 3, and some other data, 11th record and 13th record, something like that. Okay, this is what bagging is all about. So now we understood what is ensemble learning and bagging and random forest. And using random forest, we can solve these two problems. And also we discussed about the limitations. It requires more memory. The training time will be more in case of the number of the samples is too huge, right? Too high. The training time will be wet. But compared to the gradient boosting machine, in the case of random forest, it builds the tree simultaneously. Hence, the performance will be pretty faster. Okay. And the other advantage is the higher accuracy. If you want to predict whether you want to approve a loan for a person, yes or no, right? You want to predict the class level. With random forest, it will be more accurate because you are not building a single tree. The algorithm builds multiple trees, and then based on the majority voting only, it assigns the class label when it comes to classification problem. When it comes to regression problem, even in the case of regression, it creates multiple trees and it takes the average of all the trees predicted output value. This is how the random forest works.